What's up, Geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at our Chapter 4 test review, which is all about transformations, tessellations, and symmetry. So we're going to go ahead and get started. Feel free to fast forward whenever you need to, just because a lot of these take a little bit of time to show you how to do. But remember, you can always go back and rewind if needed. So translation is number 1, 6 units left and 2 units up. All you're doing is you're taking each point and counting 1, 2, 3, 4, 5, 6, and 2 up. So D prime will be here. And then P prime, if you wanted to look, there are 1, 2, 3, 4 units in between D and P. So P prime would end up being here. Q prime, 6 to the left, 1, 2, 3, 4, 5, 6, and 2 up. So here would be Q prime. And then A is 1, 2, 3 units down from that. So A prime would end up being here. And then all we're doing is we're connecting our points together to create that image. For number 2, 4 to the left and 3 down. So starting with letter D, 1, 2, 3, 4, and down 1, 2, 3 for D prime. F is 1, 2, 3, 4 units down from that. So I'm just going to use that knowledge to help me with F prime. And then I, 1, 2, 3, 4, down 1, 2, 3. It's actually going to end up where F was. So we have D prime, I prime, and F prime. And then again, you're probably drawing better straight lines than I am at this point, and that's okay. 3, a translation is now written in the algebraic rules of x minus 6, y plus 2. So that means we're going to go left 6 and up 2. So again, let's maybe start with letter F. 1, 2, 3, 4, 5, left 6 and up 2 would make F prime here. E is going to be 1, 2, 3, 4, 5, 6, up 2. And as I'm going, I'm going to start connecting. U prime is just 2 directly to the left of E. And then for I, 1, 2, 3, 4, 5, 6, and then up 2, I prime would be down here. So here we have this nice shape translated to the left and up. Next up, we have another algebraic rule. This means I'm going to be going to the right 1 and down 4. So starting with letter T, right 1, down 1, 2, 3, 4. So T prime here. Z prime to the right 1, down 1, 2, 3, 4 on the very edge. M prime down to the right 1, down 1, 2, 3, 4. And then V prime to the right 1, down 1, 2, 3, 4. Again, as you're doing these shapes, we're not changing the size or shape of them. We are just moving them. These are rigid motions. And then the last 2 translations are just using vectors. Sorry for the announcements.
Bus riders, good news! Your bus is here and waiting for you right after school. If you ride a bus, you need to head out to the front right after school when the bell rings. No Dairy Queen today, sorry. Also, intramural basketball is canceled for tomorrow after school. Intramural basketball tomorrow is canceled. Thank you.
So I went ahead and showed number 5. Sorry about that again. We're just going left 4. This is the end of the day. I'm recording this video, so you're going to hear our bell in a few minutes as well. Number 5 is just shifted to the left 4. And then for number 6, we're going to go right 2, up 1. So F will be right 2, up 1, F prime here. U would be here. And then R prime would end up being here. So it's kind of go on or overlap over itself, but still the same shape regardless. Okay, next page, we're going to be looking at some reflections. So reflecting across the y-axis means that Z prime and A prime are going to be in the same spot that Z and A are in, but P prime would end up being reflected 4 units on the other side of my y-axis to create a mirror image that way. And then this one, our x-axis reflection actually is going to reflect across each other. I think this is point Q or O, I'm not sure. E prime stays the same, so does N prime, but P prime just slips 1 down. So we have this nice shape just reflecting over itself. Okay. Number 9, x equals -2 is this line here. So U and W are once again already on that line, so W prime U prime, going to go ahead and connect those, but D prime would be 1, 2, 3 steps away on the other side. So I'm going to end up right here, and then V prime is 1, 2, 3 away, 1, 2, 3 as well. Connecting V to U, U to W, W to D, and D back to V. And then Y is equal to -1 is this line right here, where that y-axis is equal to 1. D prime is 2 units away, so 2 units on the other side. F prime is 1, 2, 3, 4, so 1, 2, 3, 4, all the way at the top, which means that T prime would also be at the top too. Okay. Next up, we've got some rotations. What I do here is I first create I write down my original points. So H is 2, 3, M is 2, 2, and P is 3, 2. And then my rule for 180-degree rotation is a -x, -y, or you can rotate paper 180 degrees, which is upside down, and then re-plot points. Okay, I like turning the paper method. It's easiest for me, but here on the computer screen I can't show you how I'm turning the paper. So instead I'm just going to go ahead and create my -2, -3 for point H, my -2, -2 for point M, and then my -3, -2, which kind of overlapped there. Maybe make an M prime here, and then I'm going to erase this and do P prime. So I've got my H, M, and P prime there. Rotation 90 degrees counterclockwise about the origin. What again I did here is I created the list of my current points. So H is at 1, 3, I is at 4, 4, F is at 4, 2, and then L is at 1, 0. And then you can use the algebraic rule of x, y is -y, x. That just means my x's and y's will change places and my y will become negative. So -3, 1 would be H prime. So 1, 2, 3, up 1. I prime would be -4, 4. So -4 up 1, 2, 3, 4. F prime would be -2, 4. And then L prime would be 0, 1 here. So again, still rotated 90 degrees counterclockwise. The other option is to do a 90 degrees clockwise turn paper, and then re-plot points. I like that method better, but if you aren't able to turn your paper, or it's just easier for you to apply the algebraic reasoning rule, you can do that either too. Number 13, now we're going to just get into describing transformations. So this one I wrote the translation rule or the vector. So here we did x plus 1, so I went right 1 and down 4. You can also just write it as a +1, -4 using the vector rules. For number 14, another translation rule, you could say x, y, and then x plus 0 or just x, and then y plus 4. Another way to write it with the translation vector is 0, 4. For number 15, that one is a reflection over y equals -2. Here's my line of reflection, and that's where y is equaling to -2. And then number 16 is also a reflection, but this time my reflection is x equals -1. For number 17, what I did here is I noticed point N started at -2, +2, and then N prime went to -2, -2. I also noticed that in the counterclockwise rotation, it looks like it went 90 degrees. So this would be a 90-degree counterclockwise rotation. about the origin. For number 18, this one is also rotation. Letter D, I just focused on that one, is at 2, -3, and then D prime switched to the opposite, -2, +3. That only gives me one opportunity, and that's 180-degree rotation about the origin. Okay. Onward to the last page of our review, question 19, identify any congruent figures in the coordinate plane and explain your reasoning. I understand not a lot of room to explain reasoning, so we'll just kind of briefly talk about this verbally. I'm going to color coordinate. So I have number 8 and number 5. That one looks like a rotation. Other ones that could be congruent, angle or triangle 1, triangle 9 is another rotation. Triangle 2 could even be thrown in there with maybe a translation added in there or another rotation. For the last two equal shapes or congruent shapes, that would be shape number 10 and shape number 3. And again, we could use maybe a rotation and a translation or a reflection, rotation, translation. 20 is when you're describing what happens for the congruence transformation that gets A, B, C to A prime, B prime, C prime. For this one, I started with a translation of x plus 2 and then y plus 0. And then I reflected over the x-axis. Some of you could have started with the reflection over the x-axis and then done your translation of plus 2 for your x, and that would have been fine as well. And then for questions 21 through 24, we're going to touch on symmetry, drawing a figure that represents a description. For line symmetry only, I used the letter H, because in the letter H, there's only one way that we're showing line symmetry, and that would be with one straight line. Rotational symmetry only means I cannot have line symmetry, so I thought of a parallelogram here. I know that's not going to be perfect, but I thought about if I rotated this 180 degrees, it would be symmetrical, and even a full 360-degree rotation also showing symmetry there. Both line and rotational symmetry, you want to think about regular polygons. So in this case, I have a hexagon here. The hexagon is going to show line symmetry with all these lines, like you can even cut it in half, perfect. And then you could also put your rotational symmetry. How I figured that out is 360 divided by 6 is going to give me a 60-degree rotation, so I can also show both of them. And then no symmetry whatsoever, I did an irregular or an isosceles trapezoid. This just means I have to rotate it 360 degrees for it to be the same shape. There's no line symmetry there either. That is all for our review today for Chapter 4. Thanks so much for tuning in, and we'll catch you next time. Have a great day. Bye.